So we say the Boyle's law, the volume of a given mass of gas is inversely proportional to its what? Pressure, if the temperature is constant. So we're going to look at it from the mathematical point. If we say that the volume of a given mass of gas is inversely proportional, which is 1 over, to its pressure, if the temperature remains constant. So from here, we have our volume, we remove this proportional sign to equality sign, and we bring a mathematical constant K, alright, which is over P. So our constant is equal to Vp. Therefore, we say V1, P1 is equal to what? V2, P2. Where V1 is the initial volume, initial pressure, final volume, and final pressure. Which means the system, when heat is being applied or whatever, the volume will increase and the pressure will probably increase, so we have our V2, P2. From here, we can proceed on to do whatever calculation we want. And graphically, we can also say that the volume, if we have a direct proportional sign here, the volume will be inversely to the pressure. And so on. There are many other symbolic diagrammatical representation which we can deal with. And about the direct inversely proportional stuff, we also have something like this. Remember, okay, when the volume increases, when the volume is small, the pressure will be big. As the volume increases, the pressure will be reducing. So when we say inversely proportional, that simply means that when the volume increases, pressure will decrease. When the pressure increases, the volume will decrease. That's inversely proportional. So the kinetic explanation of all of this. Remember I told us earlier that the collision of the gas molecules, the kinetic energy therefore gives rise to its pressure. Therefore, if the volume of the gas in the cylinder is reduced by half, then the collision of the gas molecules will increase double of the time, because the distance from where it is to the walls of the cylinder is twice. So therefore the collision increases, as such the pressure will increase. So when we reduce the volume by half, the pressure will increase double. So when we increase the volume, we fill the cylinder, the pressure will reduce by half. So that is how that goes. So in the kinetic explanation, that is how it is being revealed. So let us take some questions to see how we can go about this whole thing. Alright, our first question. A certain mass, I'm going to read it, I don't have to write it out. Then I bring out the given values and we solve. A certain mass of gas occupies 200 cm cube at 1.0 times 10 raised to the power 5 Newton per meter squared. Calculate its volume when the pressure is 2.0 times 10 raised to the power 5. So we have our initial volume, which is our V1. When the pressure increase, or the pressure increased by 2, the volume will tend to increase by 2, which means we'll go down to the final volume. So at constant temperature. So let's take our given. While I read, first of all, it is important we have what we call given. We have V1, P1, V2, P2. Okay, I say a certain mass of gas occupies 200 cm cube, which is our V1. 200 cm cube. At 1.0 times 10 raised to the power 5, which is our P1. 1.0 times 10 raised to the power 5 Newton per meter squared. We should calculate its volume, V2. So we don't know what that is. That's what I say we should calculate. When the pressure increases to 2.0 times 10 raised to the power 5 Newton meter. Okay, that is it. Remember, according to Boyle's law, they say the volume of a given mass of gas is inversely proportional to its pressure. Where we say volume is equals to K over P, making K the subject, we have Vp. Where we say that V1 P1 is equals to V2 P2. You don't forget that. That is what we're going to use to solve. So, if that is true, let me just put it here so we can always reflect. Now, V1 P1 is equals to V2 P2. We are looking for V2. So V2 is equals to V1 P1 all over P2. And this is equals to the volume V1 is 200 cm3 times the pressure is 1.0 times 10 raised to the power 5 Newton per meter square all over the P2, which is 2.0 times 10 raised to the power 5 Newton per meter square. So, when we use our calculator, we see what we get. So we have our 200 times 1.0 times 10 raised to the power 5 divided by 2, also divide by 10 raised to the power of 5. So that is 100. So our V2 is 100 cm3. So that is it about the first question. So let's take our second question. We say a given mass of gas at 55 degrees Celsius, which is temperature, has a pressure of 3.6 times 10 raised to the power 4 Newton meter or Newton per meter square, and occupies a volume of 1.8 dm cube, which is our first volume, yes. What volume will it occupy, the V2 they are asking, if its pressure is increased to 4.8? So from P1 we have gone to P2. So remember, temperature is constant. We say that the volume of a given mass of gas is inversely proportional to its pressure. What at constant temperature? If the temperature is constant, you get that. Or if it is not constant, then the law will not be obeyed. So let us bring out our given. So in question 2, given, we have our V1 P1, V2 P2. Now, a given mass of gas at 55 degrees Celsius has a pressure of 3.6 P1, 3.6 times 10 raised to the power 4 Newton per meter square, and occupies a volume of 1.8 dm cube. V1 is 1.8 dm cube. Okay. What volume will it occupy, the V2? What volume will it occupy if its pressure is increased to 4.8? 4.8 times 10 raised to the power 4 Newton per meter square. We still simply just apply the law, the formula. What does it say? We say our V1 P1 is equals to V2 P2. So if we are looking for V2, we'll make it the subject of formula, which is V1 P1 all over P2. And this is equals to our V1 here is 1.8 dm cube times P1 is 3.6 times 10 raised to the power 4 Newton per meter square over P2, which is 4.8 times 10 raised to the power of 4 Newton per meter squared. So this is equals to, so we check again with our calculator, 1.8 times 3.6 times 10 raised to the power of 4 divided by 4.8 times 10 raised to the power of 4 is 1.35. So 1.35 gm cube is our final volume. So we take another question. Our third question here, if 375 cm cube of a gas has a pressure of 770 millimeter mercury. So we have our V1 and our P1. Find its volume, the V2, if the pressure is reduced to 750 millimeter mercury. Okay, that is our P2. Okay, I have my V1, P1, V2, P2. V1 says 375 cm cube. Okay, of a gas has a pressure of 770 millimeter of mercury, which is another value or unit for pressure. Find its volume, V2. We should look for that. If the pressure is reduced to 750 millimeter of mercury. So we proceed. Our formula again says V1 P1 is equals to V2 P2. We are looking for V2 again. I guess we're going to see a question where we have to look for some other thing. So our V2 is equals to V1 P1 over P2. And this is V1 here is 375 cm cube times P1 is 770 millimeter of mercury over P2, which is 750 millimeter of mercury. So let's go. We have 375 times 770 divided by 750. 385. So our V2 is equal to 385 cm cubed. So we move on. We have more questions here. Okay, we're just done with this. Our fourth question says 200 cm cube of a gas has a pressure of 510 millimeter of mercury. What would be its volume if the pressure is increased to 780 millimeter of mercury, assuming there is no change in temperature? Remember, we say in Boyle's law that the temperature is always constant. So assuming that there is no change in temperature, which means the temperature remains what? Constant. So let's go with that. Now, okay, 200 cm cube, which is V1, 200 cm cube of a gas has a pressure of 510 millimeter of mercury. What will be its volume, V2, if the pressure is increased to 780 millimeter of mercury? That's our fourth question. We go again. V1 P1, V2 P2. V2 is equals to V1 P1 over P2, which is equals to V1 is 200 cm cube times P1 510 millimeter of mercury over P2 780 millimeter of mercury. And V2 is equals to, we have 200 times 510 divided by 780. That is 130.8. 130.8 cm cubed, which is 131 cm cubed. Three significant figures, very important. Our fifth question. Okay. What pressure will be required to compress 350 cm cube of hydrogen at 700 millimeter mercury to 300? So let's get a question. Say, what pressure will be required to compress? We already have 350 cm cube, which is our V1 of hydrogen, at 700 millimeter of mercury, which is our P1, to 300. So that is now our V2, all right? Temperature remaining constant. So we are going to be looking for P2 now. So let's take this out. What pressure will be required to compress 350 cm cube V1, 350 cm cube of hydrogen at 700 millimeter of mercury, 700 millimeter of mercury, to 300 cm cube what is the pressure? So this time we're looking for P. Here again, we have our V1, P1 is equal to V2, P2. We are looking for P2. So we have P2 is equal to V1, P1 over V2. So that's change of subject of formula in math. Someday we're going to have it treated in math. Okay, I have this already, so let's do. V1 is 350 cm cube times P1 is 700 millimeter of mercury. Your voice. Over V2, which is 300. So I have 350 times 700 divided by 300. 817. P2 equals 817 millimeter of mercury. Okay. Let's take our sixth question. A gas has a volume of 500 cm cube when a pressure of 76 millimeter of mercury is exerted on it. What will its volume be if the pressure on it is changed to 73 millimeter of mercury, assuming temperature remain constant? So we're looking for V2 this time around. So let's take this out. Okay, let's say a gas has a volume of 500 cm cube. 500 cm cube when a pressure of 76 millimeter of mercury, 76 millimeter of mercury is exerted on it. What will its volume be, V2, if the pressure on it is changed to 73 millimeter of mercury? V1, P1, V2, P2. We're looking for V2. V2 is equals to V1, P1 over P2. And this is V1 is 500 cm cube times P1 is 76 millimeter of mercury over P2, which is 73 millimeter of mercury. So I have 500 times 76 divided by 73. 521. V2 is equal to 521 cm cubed. Yeah, it's cm cubed. So this is our final volume. Okay, let's just take 7 questions and move to something else. The 7th question, we can stop there. Let me clean it up. A gas occupies 200 cm cube. 200 cm cube at 510 millimeter of mercury. 510 millimeter of mercury. If temperature remains constant, what will its pressure be when the volume is increased to 131? 131 cm cube, what will its pressure be? So we have this now. Back to our formula, V1 P1 is equals to V2 P2. We're looking for P2 now. So P2 is equals to V1 P1 over V2. That is equals to V1 is 200 times P1 is 510 over V2 is 131. And this is equals to, so check, 200 times 510 divided by 131 is 779. 779 millimeter of mercury. Okay, think we can stop it there. Let's go to another law.